Welcome everybody again to another episode of the ideaXme show that profiles the individuals behind the really big ideas that are shaping our world, inspiring the future and future creators, and for all those that like really great stories. I'm Ira Pastor, your life sciences ambassador along for the journey today. And today we have another truly fascinating guest working at the intersection of really cutting edge science as well as spirituality. We're joined today by Dr. Michelle Francl, who is the Frank B. Mallory Professor of Chemistry at Bryn Mawr College, a very distinguished women's college here in the suburbs of Philadephia, as well as an adjunct scholar at the Vatican Observatory. Dr. Francl has a Ph.D. in chemistry from University of California, Irvine. She did her postdoc research at Princeton and has taught physical chemistry, general chemistry, and mathematical modeling at Bryn Mawr since 1986. She has wide-ranging research interest in theoretical and computational chemistry, structures of topologically intriguing molecules or molecules with weird shapes, history and sociology of science, and the rhetoric of science. Dr. Francl is noted for developing a variety of new methodologies in computational chemistry. She is on the list of the top 1,000 most cited chemists, a member of the editorial board for the Journal of Molecular Graphics and Modeling. She's active in the American Chemical Society and author of the Survival Guide for Physical Chemistry. In 1994, she was awarded the Christian R. and Mary F. Lindback Award by Bryn Mawr College for excellence in teaching. She currently writes for Nature Chemistry on a variety of topics, including science, culture, and policy. And in April 2016, was named as one of the 9 adjunct scholars at the Vatican Observatory. Dr. Francl was awarded the 2019 American Chemical Society Philadephia Section Award, which recognizes an individual who, by conspicuous scientific achievement through research, has made important contributions to man's knowledge and thereby aided the public appreciation of the profession. And when she's not doing all of that, Dr. Francl also writes extensively on spirituality, has many publications in print, including but not limited to Seeking the Face of God, The Lives and Discoveries of Catholic Scientists, Not by Bread Alone, Reflections on the Scriptures for Lent in 2020, the forthcoming Waiting and Joyful Hope, Daily Reflections for Advent and Christmas, and blogs at her website, Quantum Theology Blogspot. All that being said, Dr. Francl, welcome to the show. Thanks for coming on today.
Thank you so much for having me.
It's a real pleasure.
I feel busy just listening to all that.
So we typically start off the show by giving our guests the floor for a little bit, just to sort of talk about themselves, introduce yourself, sort of, where you grew up, how you developed this interest in science and in chemistry and in very complex areas of chemistry, and a little bit your path the last few decades at the college in both teaching and some of these very intriguing areas of the world of chemistry.
I'll start with the fact that both my parents were chemists. They met and married in graduate school. So I grew up in a household where science was something that people thought about and that women thought about. You know, it never occurred to me in the 1960s growing up that women didn't do science, because my mother did and my father had women scientists in his lab. So I grew up around women who did science and in people who were interested in the world around them. So I grew up in a small rural town outside of Chicago where the bookmobile came. So, you know, books for me were kind of my door to the outside world. And when I moved to California about the start of high school, I was still fascinated by science, but also interested in kind of the intersections about linguistics. How do we talk about things? How does language shape what it is we think about? And so I took both linguistics and chemistry, stuck with chemistry as a graduate student. I took a course in quantum mechanics, and it was just like so fascinating to see this world that didn't work the way the external world worked. For me, the most fascinating thing was tunneling, this notion that you could shoot something at a target and have it go through and come out the other side. But even more troubling, you could bounce a ball toward a surface to the side of a table and it would bounce back. That's converse of tunneling, this kind of weird reflection from nothing. And thinking about how do you talk about that? How do you deal with it mathematically? I love the math part of it. So it sort of melded all of the different pieces of things I was interested in. At that point, computational chemistry was a pretty new and growing field. So it was fun to be in on kind of the ground floor and developing methods. But my sort of long-ranging interest is, things that don't do what we think they should do. Whether that's, molecules or particles or even people.
Mm-hmm.
So, and continuing to be interested in how do we then talk about these weird things. I mean, I teach quantum mechanics regularly, and students get very puzzled when I say, okay, here's a wave function, and it extends to infinity. This, some possibility of finding this electron, not just around the nucleus of the atom, but miles and miles away from it.
Mm-hmm.
And they're like, but how can that be? I'm like, I don't know. How do we talk about that? I can write you equations that show you that it's true. We can calculate what that probability is, but then we have to decide, is that meaningful, that probability? We have to decide, how do we think about these things? How much of my electrons are overlapped with your electrons, whether you're here in Philadephia or what happens if you're, in Rome at the Vatican Observatory.
Sure.
And is that overlap in any way meaningful? So those are kind of the places where things intersected. I enjoy writing, and I got kind of drawn into theology when my first year at Bryn Mawr College. Sadly, I was widowed at 29, and people deal with that in sort of all sorts of different ways. And as an academic, what I did was go back and try to take courses in theology. This turned out to be helpful in that it was something to do. Less helpful, there are no answers in that either. Evil is in the world and bad things happen. And you don't get answers necessarily by digging in. But it again got me interested in these intersections about how do we talk about things that are at their heart mystery? How do you talk about the ineffable? And so there's where the two things cross. And then I got remarried. I had 2 kids. I didn't quite finish my master's in theology because I had 2 kids, was working full time. But then I wrote an op-ed for the Philadelphia Inquirer on silence.
Mm.
And the bishop who was in charge of the Catholic paper sent me an email that said, hey, if you can write for them, you could write for us. And so Bishop Dan Thomas, who's now bishop in Ohio, in Toledo, really is the person who kind of nudged me to think about writing not just about theology and not just about prayer and spirituality, but about writing about what does that mean within a lived life. He was right. If I could write for the Philadelphia Inquirer, I could write for other places too, and have been doing so now for, I want to say 15 years, 20 years, something like that. I'm not sure what else I should and could say.
That's it's a wonderful introduction, and I appreciate you sharing all of that. I really enjoy sort of this concept of looking at mysterious things, because there's so many, whether we're talking about quantum mechanics or any other brand, the cosmos, what have you. There is just so much mystery out there, and it's always interesting to see some of these connections, and when what I call the things that make you go when when you're sort of at that bleeding edge of your discipline, and you think you understand one thing, and there's just so many sort of mysterious components left for us to dive into. And I think one very interesting place to start, just because you mentioned obviously this quantum chemistry, which is an expertise of yours, probably an area that very few people in the world understand. But we've discussed on previous shows, we've dabbled a little bit in quantum mechanic themes, so some of the basics in terms of Bohr and Schrodinger and so forth. We've also dabbled a little bit at sort of the other end of the quantum spectrum. We had Dr. John Joe McFadden on from Surrey in the UK, who is active in the world of quantum biology and sort of how sort of the very cold subatomic realm of quantum mechanics emerges in some way in sort of the warm, wet worlds of biology.
Mm-hmm.
Quantum chemistry, it seems, is an interesting bridge there between these two worlds that, well, one is very subatomic, the other is macromolecular, and photosynthesis and olfaction and all these interesting things we don't think have quantum dynamics to them. Talk a little bit, if you would, take us a little deeper into quantum chemistry and what it really is all about, and sort of some of the connections you see between these two worlds, if you would, and maybe how it bridges these two worlds.
Yeah, chemistry is often the bridge between biology and physics. And there's a great graphic of someone who looked at, I think it's 8 million clicks through the scientific literature to see how people moved from one paper to another. And you can see like the collection of physics, you can see biology, you can see chemistry, you can see subfields, and you can kind of see where those thin bridges are between spaces.
Mm-hmm.
And certainly, chemistry kind of sits between that physics piece and the biology piece in a lot of ways. The interesting thing for me about that graph is how tight the little bundles are, like that we really do live in our little ivory towers, and that
Sure.
there are not as many bridges as maybe we might wish there were. So as a chemist, I'm interested probably fundamentally in molecules. And the big question then is, what is a molecule? And we see molecules, maybe the iconic one is water, right? With the little
Sure.
oxygen in the middle and the two little Mickey Mouse ears of the hydrogen atoms. But that's a very tiny molecule. But hemoglobin is also a molecule, just a much larger molecule. And presumably the rules apply to both water and to hemoglobin. And then, hemoglobin assembles into red blood cells,
Sure.
right? Cells are assembled from molecules. So one big area of research people these days are interested in is membranes. So, what's that thing that encapsulates a cell? How can you model that quantum mechanically? How can you model that using classical physics? So there's also kind of these two other places where it bridges to physics. It's not just quantum mechanics, but it's also in kind of these physical ways, both on the macroscopic level. So how do flows work, but also on the microscopic level, how does a membrane assemble? How does it know to self-assemble? And I use the word know as if the molecules have some kind of mind. And so you have this kind of, odd way that chemists think about things as if their molecules have sensibility and minds of their own. So at the quantum mechanical level, what I'm interested in is those sort of fundamental particles, and particularly the electrons, which sit in a field of the nuclei. So it's sort of like the positions of the atoms, and then you sort of dump a bunch of electrons in and ask what happens. The other questions that you can ask as a quantum chemist is not just where do those electrons go in a static structure, but ask yourself, what is the best structure that is determined by that field of the electrons and the nuclei together. So it allows you to probe molecular structure in a way different. You don't have to have the stuff in your hand. I can imagine a molecule. So my current sort of fascination are with these molecules that have Möbius topologies. So they have just one side and one edge, and they're really weird and wacky, and they have some interesting properties as far as chemists go. But no one's made the one I'm particularly interested in at the moment. And it doesn't matter because I can still experiment with its structure using all this quantum physics framework to probe the structure of the molecule. I can ask questions about the electrons and their behaviors in a magnetic field. I can ask questions about if I move this, if I add something in, what will happen to the structure? So if I pull out this piece and stick another piece in, will it still be, twisted up the same way? So it's that sort of fundamental understanding about molecules as a collection of atoms, sort of like those little building blocks, which then can build into these larger structures, and trying to understand why do they have those structures? What's the underlying drivers for that that sort of thing. And so biologists, are interested in the membrane in the end, right, in the cell, or they're interested in, how hemoglobin, if you have a miscue in the, for example, sickle cell anemia is a miscue,
Sure.
right? One wrong amino acid and then things go awry in the shape of the cell, not just in the hemoglobin, but also in the shape of the cell in which it's incorporated. So those things are kind of that connection between structure and function. And that may be the bridge that I walk on most of the time. So at one point I worked on the problem of Taxol, which is an anti-cancer drug, and trying to understand how that worked in the cellular thing. So it was a great collaboration with someone who was doing in vivo work, in vitro work, and then we were doing what these days people call in silico, so in the computer. And so it was really a fun collaboration to be a part of, and to be able to give people some sense of, if you're proposing this mechanism in the cell, I can test it out in silico and say, these are good possibilities, these are possibilities lower down on your, I can't generally rule things out, although sometimes I can, but I can sort of order things. If you want to explore something, this hypothesis looks stronger than that one.
Fascinating. Really fascinating.
To me, this is a fun space because I can sort of use the same tools and do a whole bunch of different problems. And so the opportunities for collaboration are really fun.
Yeah, especially we've touched on sort of this theme of in silico on previous shows in areas like drug development,
right? Yeah.
Like even trying to some sort of model physiological systems so that one day, and it's not happening soon, but there may be a possibility to do in silico clinical trials in the future instead of having to test drugs on thousands of people. So yeah, that's really really neat.
There's some really neat. And there's some really neat emerging places using sort of artificial intelligence to solve these things, rather than, I use what is essentially brute force solution of these differential equations. But there is some really fascinating work. There's a paper out in, what is it, Nature Chem, about using artificial intelligence to solve the Schrodinger equation.
Wow.
Which is, it's like opening a whole nother door, and very cool.
Definitely. And they an in silico Schrodinger cat. So moving from chemicals now to sort of the cosmos, you in 2016 you get this very prestigious role at the Vatican Observatory as an adjunct scholar. You get to visit Rome. You work with the physicists there on various projects. I guess you get to look at the cosmos, but also at what the cosmos brings us in terms of meteorites and other cosmic objects, and you're working on chemistry and material sciences with regard to that. Any interesting discoveries, things you're working on now in terms of stuff that's coming from ex Gaia, and tell us a little more about the types of things you're working on at the observatory.
So boy, COVID has disrupted, all sorts of things, including I'm on sabbatical leave, and I had planned to spend a chunk of that at the observatory in Rome. So I'm not, which is, in the grand scheme of things, is a small disappointment. There's a lot bigger things to worry about.
Surely.
So most of what I've done as far as collaboration at the observatory, there's been kind of twofold. They have this fabulous meteorite collection, one of the largest in the world, and it's understudied. So one of the things that they're working on is sort of just a methodical study of all these different meteorites that they have there. There's a lot of collaborative work on this, a lot of material science. And Bob Mackey is now heading that up. Guy Consolmagno has sort of been the curator there for a long time. He's now the head of the Vatican Observatory. And Bob Mackey has taken over as the curator of meteorites. Some of the fun things I've done is it's kind of gone the other way. I've taken some of the techniques that they've developed and brought them back to Bryn Mawr, where my students are doing, as part of their laboratory training, measuring material properties of meteorites.
Okay.
And that's been kind of a fun backset. Bryn Mawr has a catalog of meteorites too. And if I can get my students well enough trained, the goal is to let them then, use the meteorites in Bryn Mawr's collection and add to the database that's getting developed by the observatory. And the fun of this is letting students try samples that it's okay if they, do something wrong.
Absolutely.
Because the trouble with meteorites is, of course, these are, one-of-a-kind samples. And so, you really don't want to let novices loose on them.
Not at all.
Which, really I think would include me too. So, but it's been fun trying to develop that methodology and seeing if we can get it to the point where, in fact, we could add to that database there. Guy Consolmagno and I have collaborated on doing some sort of history of science pieces. We did this sort of recorded book about great scientists, great Catholic scientists, which was fun to do and fun to explore sort of the who does science, right? We have this notion about it's done by, European men, but really it's much, broader than that. And even historically is much broader than that. And so some of the fun of that was pulling out the unexpected people, which, goes back to I'm interested in things that don't do what you think they ought to do.
Sure.
And so that's been a big project. And then I've been working kind of on this sort of notion about how do scientists talk about their science and what does that mean about what science gets done and how we move forward. So one of my recent pieces is to think about this notion of chirality.
Sure.
So that molecules are mirror images of each other, and the different mirror images can have different properties, kind of, surprisingly. This is a problem that's related to the cosmos because it's sort of how does chirality arise in the cosmos, right? Randomly, you should get equal amounts of each, but in fact, life on Earth is based on essentially on one-handed side. There are a few, weird exceptions. So how does that work? And is this chirality, is it a binary thing? You're left-handed or right-handed? Or is it some kind of continuum? Some things are more left-handed than other things are. So for example, you can take a tetrahedron and I can color its sides. And I can make a mirror image of it and you would never confuse the two.
Okay.
You would find them impossible to superimpose on each other. Or I could take a piece of paper and just fold up the corner and color it in. And I could make a mirror image of that. But if I handed you those two pieces of paper, you would have to look very carefully to distinguish which one was the left-handed one and the right-handed one. So you might say that's less chiral. And this is a big argument among chemists and biologists. Is chirality a binary thing or is it a continuum? If it's a continuum, then you can start talking about, how do you pass it on a little at a time rather than all in one fell swoop. Right now, it's sort of a template idea. If you're left-handed, you make things that are left-handed and that are completely left-handed. But if you're just a little bit left-handed, maybe, you just give a little bit more left-handedness to something.
Got it.
So understanding how we think about this also understands underscores the questions we're asking, underlies the answers that we're able to accept. So thinking about that, and that was, a fun exploration to do, but it has to do with a kind of intersection about our rhetoric and our choice of terminology and the questions we're asking and the answers that we're getting and expecting. So that's probably that was the piece I worked on when I was there last summer, not last summer, I guess the summer before now. Summer's over, sad to say.
Yes, it is. And hopefully we'll get through this and you'll be able to get back there more often to work on some of these projects further. Really interesting.
Yeah, no, it's a really rich set of colleagues. Every time I go, there's somebody different there. It's been an extraordinary experience to be a part of.
Moving now from the cosmos to something a little bigger, as we make this bridge. And if I may just, I wrote down a little a bit here from your website, if I may quote you. I believe in God. I also believe in evolution, quantum mechanics, particle physics, anthropogenic climate change, the Big Bang Theory, and perhaps even the Higgs boson. I'm a scientist and a practicing Roman Catholic. I write science. I write about science, digging into the way scientists do their work and trying to imagine how we might do it better, whatever better means. And I write about God, God in the laundry, God in molecules, God in all things. And it's probably, a couple of months ago, we had Ilya DeLeo on from Villanova and Meg Institute, and I know you've spoken at I think some of our conferences in the past. Her work, obviously, our background as a pharmacologist, and a lot of mystery as well in pharmacology, not just the way, why a certain drug binds to a receptor, but the fact that it does it so perfectly across 50 trillion cells, and so forth. Your blog site is called Quantum Theology. Are you working at the in drawing connections between the subatomic world and the essence of spirituality, or take us a little bit on what quantum theology is all about, and if you can make a little connections. I don't know how much you work with Ilya and some of what she speaks about, but walk us a little bit through some of what you're doing, some of the focus of your own writing in this area.
I know Ilya both from her work, but also I see her at church.
Sure.
So every once in a while I'm sitting two pews behind her.
Good place to know from.
And well, sometimes interesting, given what the readings might be, and someone's preaching about them, that I'm thinking, here you have the world expert, on, for example, Genesis sitting, two places in front of me, and I'm wondering what she's thinking. But quantum theology started, I don't want to say as a joke, because it's not quite a joke, but the title of the blog came from sandwiching together the two main areas I was writing in, quantum mechanics and theology, without really an attempt to merge them or reconcile them. They were just two things I did. And so I put it together. There is a quantum theology. So there's a book entitled Quantum Theology, and I don't really go quite there. For me, what I'm thinking about is, and I'm giving a talk next month called Amid the Burning Layers of Grace, to think about what it is that what's a contemplative approach to science look like. So maybe the theology, the spirituality, and the science mix that I'm thinking about is, what's a contemplative approach to science? What can we learn from contemplatives about ways to do science that's productive for science, that doesn't run rough, that doesn't treat the contemplative part as mechanical, in the sense that if you do this, this will happen. There's a great joke about, that meditation doesn't ensure enlightenment, it just makes it, more possible. Makes you more accident prone or more likely to trip over enlightenment than anything else. And so what is it about these contemplative frames that might make scientists more able to trip over the mysteries of the universe and uncover them? So that tends to be the spot that I write about, where science and spirituality intersect, is to think about that. And also to think about the converse, what is it that scientists have that would be helpful for contemplatives to think about? That, that it's a two-way road. Paul VI, in the closing remarks for Vatican II, talked about, there was a shout out to scientists in it. And of course, we tend to think of these things as really separate, right? There's the church and there's science. And if we think about it at all, it's, Galileo, and the church doesn't, support science, or religion doesn't support science. Somehow it's, two warring armies set up. But at the closing to Vatican II, Paul VI talked about being on the same path. That this interest in the truth and uncovering the truth, articulating the truth, making the truth visible, or something that both scientists are engaged in, as well as theologians and people of faith. They're both interested in these things. So we share paths, and we share the same sorts of, trials. We can't get words wrapped around. I mean, when I want to talk about tunneling, it's hard for me to wrap words around that. If I want to talk about God, it's hard to wrap words around that.
Sure.
We struggle with some of the same problems. We're using different tools, and I don't want to conflate them in that sense. But it is that sort of crossing of paths, and I'm interested in that crossing of paths. So I'm interested in thinking about, what is it that contemplatives might bring? So things like an unforced pace of work.
Okay.
So there's a fair amount of evidence in the history of science literature that great discoveries don't come from forcing it.
Sure.
And, we try sometimes. I mean, the response to COVID and trying to find a vaccine, we're, pushing hard. But that real breakthroughs often come kind of accidentally.
Oh, yeah.
And they come sort of from long kind of productive thinking about things, or playing with things, or toying around with things. One of the things to me that's interesting is, so the discovery of X-rays, the first X-ray was taken in Philadephia. It was not taken by Röntgen, and there's a very famous picture of his wife's hand with a wedding ring on it. And that's always touted as, kind of one of the first examples of an X-ray taken, and he did it in a few weeks, holed up in his lab. But it turned out that two guys in Philadephia had done it. They had one of these Crookes tubes that sends out radiation. They had a stack of unexposed photographic plates. They put their trolley tokens on top.
Okay.
And when they developed the plates, there were the images of the trolley tokens on top, these discs. And they didn't know what they were, because no one had ever taken an X-ray before. And they didn't have a lot of time to deal with it. So they sent each other, this is before email, right? So they sent each other telegrams back and forth across Philadephia. And in the end, they just, filed the plates and just left it as a mystery. They didn't know what it was. But they didn't have the time, they were engaged in other projects, the time to kind of sort of sit with it and think about what might happen. When Röntgen published the X-ray, they saw it in the newspaper and they were like, now we know what we have. So there's this notion of kind of the unforced pace, and contemplation kind of supports that notion. You sit and you wait. And there's, the Saint Romuald who talks about, sit in your cell and your cell will teach you everything. Sit waiting on God and see what happens. So I think that's one thing that scientists might take from contemplatives. There's this sort of notion about the cultivation of wonder and awe.
Okay.
I think sometimes we see science, particularly from the outside, as a way to kind of dismantle the universe, that we know how it works, and then putting the pieces back together in a way that works for us. Sure. Right? So, tunneling is a fascinating phenomenon, but you can use it to make a scanning microscope, and you can see, down to the atomic level. So understanding that also means that we can use it as a tool. We can use it as a tool. The world's smallest advertisement is for IBM. Somebody took one of those scanning microscopes and put the atoms into the letters IBM, right? Yeah. So, we can use these things for, good or for ill, or even just for fun. But there's something kind of mechanical about seeing the universe that way, and very transactional. I do this to the universe and the universe does this back to me. But there's also kind of a joy and a wonder in all of it. Edward Purcell, who won the Nobel Prize for NMR, for this stuff that now underlies MRI, magnetic resonance imaging. Sure. Chemists call it nuclear magnetic resonance, NMR, and physicists do. But when they made it more popular, when they began to use it for medical work, the word nuclear was frightening, so they took it out. So we end up with MRI, but NMR. And he talks in his Nobel address about having made this discovery about the way that hydrogen atoms behave in a magnetic field. And sometimes we talk about them precessing or spinning. They're not really spinning, we don't think. It's another one of those mysteries and how do you talk about it things. But the point is that Purcell talks about walking outside and looking at the snow and saying, seeing in the snow, all of a sudden imagining all these hydrogen atoms in the water precessing gently in the Earth's magnetic field. And it's this sort of sense of awe and wonder. And he says it's the gift of a scientific discovery is having new eyes to see the world with. And it's this really beautiful reflection on sort of the mystical end of science. Just, you know, this notion that he looks around and you see a pile of dirty snow on the doorstep and he sees all these hydrogen atoms, you know, gently moving in the Earth's magnetic field, which means he also understands that the Earth's magnetic field is there, you know, flooding this space. So the sense of awe and wonder, I think, is another piece, and it's a driver for science. So there are a lot of scientists who do what they do because they're just fascinated. They're just drawn into these mysteries. It's not a mechanical or transactional thing at all. So I think it's another space where we can sort of give scientists permission to be contemplatives, to be, in some sense, mystics. You know, sometimes I give a talk that's has a title, are scientists really mystics? And try to, you know, use the framework of, you know, what is a mystic, what's mysticism, to talk about what science is beyond this kind of, you know, I mix these two things together and I make a new molecule, which can feel very, very mechanical, but I think is really not, drives most of the scientists I know, is not that, even though they do it well. So I think there's those pieces to it. And there's the ability to kind of be comfortable with multiple readings of things. You know, the Christian tradition views Jesus Christ as God and man simultaneously, without trying to resolve how does that totally work on every level. Quantum mechanics look at electrons and say, oh, wave and particle. Without, you know, you can't totally resolve it into one or the other. It has behaviors like a wave, behaviors like a particle. You can treat it one way when it's convenient, another way when it's convenient. But this ability to kind of be comfortable with those multiple readings is, I think, something else that, you know, mystics, contemplatives have to offer scientists who sometimes, at least in my experience, my students are really uncomfortable with that. But which is it? You know, we tend to want at the beginning, when we start as scientists, we think of things, we want the right answer, right? As opposed to, well, here's an answer that works in this context, and here's an answer that's helpful in that context. And my students are like, but which one and how do I know? So part of that comes, I think, from teaching science for all these years to, you know, really smart women who are really curious about the universe and have come to a place where they're not just studying science, but a wider range of things. So I think that's a piece of it.
What Einstein's phrase was, we had something similar to that, you know, anyone that can't sit and just for a little while and look at and consider all this so mysterious is, you know, shouldn't be doing this stuff. Really, very, very interesting and very elegant the way you talk about it. Anything, obviously we're both locked down here for a little bit on the East Coast. Any new projects coming up? I don't know if you have any travel plans, but anything you can talk about that's not confidential on the, whether it be on the observatory front, the chemistry front, new partnerships, anything else you can tell us about?
I'm going to talk about what I'm doing on sabbatical maybe, and that might be,
please.
You know, say something about where I'm going in these places. So, you know, everything got upended and my chance to kind of travel and go other places got unplugged. But that opened up other possibilities. So at the moment I'm working, I'm finishing a book about prayer, which is like a huge topic and is terrifying to write about because it's a huge topic and lots of people, you know, far better than I have written about it. So that's a sort of side project. But the two things I'm working on leave are some more essays for Nature Chem, but also a bigger book thinking about these issues, about what does it mean to approach science from a contemplative stance.
Mm-hmm.
So I would say it's in the early stages of things, in that, you know, I have an outline, I'm working on a book proposal, but this notion about, you know, how does a contemplative stance work for scientists, and where does it not work, right? I
Mm-hmm.
think, you know, trying to, you know, you don't want to shove something in to fit. I'm missing the chance to talk with all my colleagues at the observatory, who are people of faith and also people of, you know, really good scientists. And sometimes it's helpful to bounce ideas off. So I'm kind of missing that piece of things. And Zoom works. I mean, you know, I can call people and talk to them, but it's not the same as the observatory. Is this wonderful custom is every morning at 10 o'clock. Everyone gathers for coffee.
Hmm.
And it's not a long gathering. I want to say 20 minutes sometimes. But it's a chance to say, you know, what are you working on today? What are you up to? Ask questions, float a question. And sometimes, you know, I'll, you know, finish my, you know, cappuccino and we're still deep in a conversation. So it'll be, you know, the starting point for a longer conversation. And that's something I'm definitely missing. And so trying to, you know, have with people when I run into them on Zoom, catch them and say, you know, do you have 10 minutes to, you know, talk through something with me?
And have a cappuccino.
Right. And yeah, I don't make as good a cappuccino at home as Alessandro makes, I have to say. But you know, but a good cup of tea is fine too. So that's one project. And the other project I'm working on, and this is much further along, I mean, in that I have a whole manuscript, is about a book about writing for scientists. And when I say that to scientists, they think, oh, a book about how to write grants and how to write a paper, you know, and then it should have an abstract and an introduction. And it's like, this is not that book at all.
Okay.
This is the book about how do you write about your science long before you get to the paper. How do you use science? Isaac Asimov said that writing was a way of thinking through his fingers. And this is a book about helping scientists think through their fingers. And so it's filled with writing prompts and encouraging them to develop in some senses, slightly contemplative practice of writing at the end of every work day in their lab. And to use some of the writing prompts as frames. And some of them are silly. You know, if you had a lab superpower, what would it be? Which is silly in the face of it, but is also asking, what's your biggest problem? It's another way of saying, what's your biggest problem, right?
Sure.
You know, you're having trouble crystallizing that enzyme, the magic power you want is, you know, wand to wave and say, make it crystallize. But it's a way of helping people focus on what's the big problem that maybe you're not seeing otherwise. So it's questions like that that are posed, and ways for them to, you know, sharpen their skills of observation. Can you describe what your molecules taste like? We don't taste our molecules anymore. I hasten to say, we used to taste our molecules. If you look back 100 years in literature, there's reports in the standard report, there's the taste of the molecule. It's terrifying.
I'll tell it to Albert Hoffman.
Right. So, you know, you definitely don't want to do that anymore, but what does your molecule sound like? So again, trying to sort of get people to come at things sideways, a little bit of lateral thinking, and a framework for doing that. And it's been a really fun project and book to think about.
Absolutely.
And so now I have a full manuscript, and the goal is, before I come back from sabbatical, to send it off to an editor and see what she thinks. So. So that's probably the biggest project that's sitting here. And it sort of feels like a combination between this notion about, you know, what is it that contemplative stance has to do with science, years and years of teaching students, and also wanting scientists to have this access to these other tools that I think we don't have so much access to. And so I've been giving writing workshops for like, I want to say 20 years for scientists. And so a lot of these prompts come from, that sort of workshop. And my favorite comment from somebody at one of them was a biologist who said she came because her chair said she should go. And she said, I'm a biologist, I'm not a writer. But by the end of the thing, she said, I realized what I am is a writer. I write grants, I write, proposals, I write articles. And she said, I write all the time. And she hadn't let herself think that that was part of her toolkit. And once she began to think about it, that's really part of her toolkit and not just a horrible distraction or a painful process. I want people to have a little bit more joy in writing and view it a little bit less as kind of a penitential rite that scientists have to go through, which I think sometimes we think of that. Grant writing is certainly a penitential thing.
Oh yeah.
You write in hope. I think the title of my new book, Waiting in Joyful Hope, is the antithesis of what you do when you write a grant, because I think what you do is you wait in pessimistic hope because you know what the chances of funding are. And so, you write, there's hope because you wouldn't have written it if you didn't hope, but you also know better than to really hope. And so it's, it's an antidote to that, I think.
Yeah, totally. Really neat.
It's been a really fun project to think about and to work with my students on. So that may be the thing I miss most about sabbatical, is not being in the classroom and not working with my students. So
hopefully back soon.
Hopefully we'll be back soon. Well, I'll definitely be back in the spring off sabbatical. The question is, what will that look like? I'm slated to teach a course actually on writing science and a laboratory course where we'll probably do some of the meteorite work. And I have no idea what it's going to look like. And
we'll see.
We'll see.
We'll all see.
That's part of the, the non-judgmental part about, my sort of approach to life, and which I think is kind of fostered by this, delving into the spiritual end of things, is that, there is nothing I can do about it other than, what I can do. And so one can just, wait to see what unfolds. There's a beautiful poem by John O'Donohue that's like 5 lines long, and where he says, I want to be like a river surprised by my own unfolding. And when I, you asked me the question, like, how did I get where I am? I'm thinking, I am a bit surprised by the river of unfolding. If you'd asked me when I was 10, I would not have imagined any of this. So,
coming back to you, obviously, you've had a fascinating career in academia, at the Vatican, meeting probably all sorts of very interesting people at conferences and scientific groups and discussion groups and so forth, in church. Are there influencers, mentors, teachers, other folks that have inspired you that you might want to mention, shout out to at this point, that, if it wasn't for them, Michelle Francl would be practicing medicine or selling real estate or doing something totally different than this.
Teaching second graders. I sometimes wonder, why did I end up doing this and not teaching second graders?
I know why I didn't do that, but that's a different topic.
Yeah, I actually do know why I don't teach second graders. Nothing against second graders. They are wonderful people, but there's something about being at the other end of that.
Sure.
I'm going to say that there are certainly people I look up to that, there's Pope Francis in some ways.
Okay.
For me, is kind of this icon of someone willing to speak the truth about people on the margins, someone willing to say things about science. And I really kind of appreciate that kind of space that he inhabits. I got to meet him once. I did not talk about science and religion with him,
Hmm,
but I did make him laugh.
that's good.
And yes, my Spanish was really bad. So I'm sorry, Mrs. Goethe, but I didn't quite manage to get it out. But certainly Sherry Rowland, who won the Nobel Prize for the discovery of the
Okay.
ozone depletion in the atmosphere, was my freshman chemistry professor.
Wow. Okay.
And I learned, and then I worked with him. I did a research project with him when I was a graduate student. So I worked with him both as this very novice chemist, as a first year student, and then as a graduate student. And he was an extraordinary man in so many ways. And I think what I learned from him was, one, when he taught, he taught. So he was testifying in front of Congress and flying from California to Washington, D.C., and I would see him on the news. But he was in class with us when he was supposed to be in class with us. And he had office hours, and here I was, this, 18-year-old with basic questions about how to calculate something. And there he was in his office, and no sense at all that there were myriads of other demands on his time. When he was present, he was entirely present to what he was doing.
Okay.
He thought about things laterally. So he had the weirdest exam questions ever. And that certainly has had an impact both on my teaching, but I think also on my interest about how do we think about things sideways and where does that get us? But he was also a man of incredible standards and ethics. I remember coming up and I thought I found this paper and I was excited. I said, here, I found the structure that we've been looking to find. And he looks at it, he looks at the paper, he hands it back to me and he said, did you read the whole paper? I said, no, I just read the abstract. And I said, but this is the structure we've been looking for. He said, I encourage you to read the paper and then come back. So I went away, read the paper. The abstract was wrong. The abstract was written and the paper said something different.
Ah.
And he was already aware of this paper, which again says, here's somebody who's managing to keep track of all these different ends. But it was a really important lesson about reading the whole thing, and not just focusing on the title, not just focusing on the headline, but reading the whole thing. And it's a lesson I have not forgotten, is to read the whole thing, to look for the nuances, to make sure that you understand the context something is written in. And the last thing I learned from Sherry Rowland was that his family mattered. His son was badly injured in an accident, and his son he turned his attention to taking care of his son. And again, here you have a world famous scientist who would eventually win the Nobel Prize, and yet, he made it clear with his choices that family mattered.
Yep.
And so to see kind of all of that in one package was really inspiring as a young scientist. And I would see him at conferences and I would think, why would you ever remember who I was? But he would always, clearly remembered who I was, where I was, wrote me a nice note when I got, the job at Bryn Mawr, when I got tenure. And I really, try as I do my own science to think about those things, to think about holding those high standards, to paying attention to the nuances, and to being really present to my students, no matter what else is going on. And that it's okay and important to care about things beyond science, that, scientists are not just about their science, but they're about their families and their communities and the fate of the world. So I would say that if you're going to point me to somebody who made a big difference in my life, both from the science I learned from him, but also from how to be a scientist, I would say it was Sherry Rowland.
Wonderful, wonderful. Really appreciate you sharing that. It was a wonderful way to encapsulate everything and
Yeah.
wrap up. And I'm always I stand in awe of folks like you and the people that you've worked with, and just it's just nice to see how through science and through that whole world that we create, as you have, in creating creating the future and creating the next generation of thinkers. And it's just really very inspiring. And so I thank you for that
Well,
wrap up.
well, thank you. I mean, it's been a privilege to work with those people, but it's also been a privilege to teach my students. And both of those are things that, you know, I'm really incredibly grateful for.
Absolutely. For everybody that's going to be watching this episode on the YouTube channel or listening on the various podcast networks, you've been listening to the amazing Dr. Michelle Francl, Frank B. Mallory Professor of Chemistry at Bryn Mawr College, adjunct scholar at the Vatican Observatory. Check out her Blogspot quantum theology website, her personal website, and just as a link at Bryn Mawr College itself. Michelle, thank you for taking the time out of your schedule to come talk with us and share your stories. Thank you for everything you've been doing in the world of science and chemistry. And as we say on the show, thank you for helping move the human story forward a little bit. It's really been a pleasure listening to you and an honor meeting you.
It's been a pleasure to talk to you. I really appreciate the chance to think through these things with someone else. Thanks so much.